Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to look at multiplying radicals. Okay, so I have the square root of 3 here and the square root of 7. And right now I kind of consider these as being part of two separate rooms. And what we want to do is kind of take the analogy of a house and put them over one roof. Okay, so that's what I'm going to do here is I'm going to take these two separate rooms and build a roof over them. So this is equal to this. And this is completely and totally allowed. I'm allowed to take both of these and move them under one radical sign. So, and then I can just simply multiply the numbers together. So I multiply 3 and 7 together, I get the square root of 21. Okay, now I need to try and simplify this. So the square root of 21, what I'm going to try and look for are perfect squares within 21's factors. So all of the factors of 21 are this. They're 21 and 21, and 3 and 7. And what I want to do is try to look for perfect squares. Now I do see one perfect square, which is 1, but 1 is kind of a useless perfect square, so we're going to ignore it. That leaves me with 3, 7, and 21, none of which are perfect squares, which tells me that this is simplified, and we're done with that one. Okay, so we want to put these two under the same roof again. So I'm going to do the exact same process. I'm going to write a larger radical sign, and then I'm writing my 10 and 2 underneath both that radical sign. Okay, so 10 times 2 is 20. I want to simplify this, so I'm going to look at the factors of 20 and see if I can find any perfect squares. So the factors of 20 are 1 and 20, 2 and 10, and then 4 and 5. And I can see that there are two perfect squares. There's one, which we can ignore, but there's also 4. So what I'm going to do is under the same large radical sign, I'm going to write the two factors of 20 that have a perfect square in them. So that's 4 and 5. Okay, and then I'm going to simplify this by separating them and then finding the square root of 4. Now the square root of 4 is 2, which leaves me with 2 square root of 5. And 5 is not a perfect square, and so this is perfectly simplified and done. Okay, let's look at this. This is the cube root of 2 and the cube root of 4. Now, on this particular question, we're going to do the exact same process. Okay, I'm going to write a larger radical with my 3 here. So that's the cube root of 2 times 4. Cube root of 2 times 4 would be the cube root of 8. Now, I want to think of 3 numbers that are the same that multiply together to give me 8. And in this case, 2 times 2 times 2 multiply together to give me 8. So that would tell me that the cube root of 8 is equal to 2. And then this is simplified, and we're ready to move on. Let's have a look at this one. This particular question is going to be using the distributive property. So I need to distribute this 5 square root of 3 inside the brackets. So I'm going to multiply 5 square root of 3 times the square root of 4, and 5 square root of 5 times the square root of 3 times the square root of 5. So I'm going to rewrite this problem as 5 square root of 3 times the square root of 4. Okay, so that's this times this, and I'll use a different color for the next one here. So now I'm going to multiply 5 square root of 3 times the square root of 5. Now there's an addition sign right here, so I'm going to put that in the middle. And I'm going to, actually, the addition sign that I really need to care about is the one that's right here. So now that I think about it, that's the more important addition sign. And it's a ghost. You don't see it there, but you can assume that it's positive. So this is going to be 5 square root of 3 times the square root of 5. Okay, and now I'm ready to solve this. So solving the red one first, I'm going to multiply, and I'm going to separate these out a little bit. But one of the things that I might notice first is that the square root of 4 is actually equal to 2. We just saw that in the last video. So I've kind of separated this. There's a ghostly multiplication sign right in here. So if you imagine there's a ghost right there of a multiplication sign. So right in the middle there, There's a ghostly multiplication sign. So I've kind of separated my 5 from my square root of 3, and then I've solved the square root of 4. Let's look at the next couple of multiplication problems here. So this stuff. And what I'm going to do is, again, separate out these two. Okay. And now I'm ready to multiply. Now, on the red one here, what I'm going to do is I'm going to use something called the associative property. The associative property would tell me that 3 times 2 is actually the same as 2 times 3. And so I'm allowed to change the order of the terms in a multiplication problem. So I'm going to move this 2 next to the 5, just like this, and then multiply it times the square root of 3. On the green side here, I'm going to multiply 5 times, and I'm putting these two together. Okay. 5 times 2 is 10. Oops, wrong color. 5 times 2 is 10, so 10 to the square root of 3. Plus 5 times the square root of 15. Now, I should look to see if I can simplify the square root of 15. So the factors of 15 are 1, 3, 5, and 15. Now, once again, there is a perfect square, which is 1, but it's a useless perfect square, so we're not going to use it. 3 is not a perfect square, 5 is not a perfect square, and 15 is not a perfect square. So this is simplified. And there is one other step. I could factor out a 5 out of this, but we don't really need to do that right now. Okay, here we go on this question. On this particular question, what we're going to be doing is we are going to be doing the distributive property again. But instead of distributing just one factor, we actually are going to be distributing this whole thing. So this gets multiplied times the 2 square root of 5, and this gets multiplied times the 3 square root of 2. Okay, so let's get started on that. I'm going to multiply this whole thing times this term. I'm multiplying this whole thing times this term, and then I'm going to be multiplying this whole thing times this term. And once again, I'm going to be using different colors here to hopefully make it a little bit clearer. So let's start with blue, and I'm going to be multiplying 2 to the square root of 5 times negative 2 square root of 3 plus 3 square root of 2. Okay? I'm going to switch to green. Now, on the green side here, I'm going to be multiplying this, the negative 3 times the square root of 2 times, again, 2 square root of 3 plus 3 square root of 2. Okay? So this right here gets multiplied times both of these terms. All right, so I'm going to switch to the blue side here, and I'm going to distribute this 2 to the exponent 5. I'm distributing it to this term and then to that term, and then I'm solving. I'm really going to end up with 4 separate multiplication problems. So I have 2 to the exponent 5 times negative 2 to the exponent 3. And I'm actually going to switch to a different color here for this one, which is the second distribute, this one right here. So the first distribute is still in blue. The second distribute I'm doing in a different color. So I'm multiplying plus, because again, there's a ghostly plus right here. So I'm making a plus right there. So positive 2 to the exponent 5 times 3 to the exponent 2. Okay, I'm going to use 2 colors on this because, again, I want you to see this ends up being just 4 multiplication problems. So I'm going to use a green color to multiply this times that, and I'm going to use the black color to multiply this times that. Okay, so here we go. Starting with green, I have negative 3 to the exponent 2. This negative comes down with it times negative 2 to the exponent 3. Switch to black here. I have negative 3 to the exponent 2 times positive 3 to the exponent 2. Okay, so time to solve. Starting with this, I'm going to be multiplying, pulling these apart a little bit. Oops, going to switch to a different color. So for the blue one here, I am doing 2 times the exponent 5 times negative 2 to the exponent 3 times. Okay, switching to the red, and I'm just doing one step at a time here. 2 to the exponent 5, I'm multiplying there, times 3 to the exponent 2. Okay, switching to the green. I'm in a sense, pulling these things apart. Times negative 2 to the exponent negative 3. Switching to the black here. Negative 3 times 2 to the square root of 2, and 3 times the square root of 2. Okay. I'm going to put together my whole numbers with whole numbers and my my integers with integers and my square roots with square roots. So I'm going to rewrite this, and I keep forgetting to switch colors, but here we go. 2 times negative 2 times negative 5, or the square root of 5 times the square root of 3. In the red, I'm doing the same thing. 2 times 3 times the square root of 5 times the square root of 2. In the green, 3 times negative 2 times the square root of 2 times the square root of 3. In the black, negative 3 times the square root of 2 times the square root of 2. Okay? Now, I can multiply these together. So positive 2 times negative 2 is negative 4 times, let's see, this would be the square root of 15, because the square root of 5 times the square root of 3 is the square root of 15. Okay, here we go. 2 times 3 is 6, and the square root of 5 times the square root of 2 is the square root of 10. Going on to the green. Good morning, everyone. 3 times 2. For the new high school students from grades 9 to 11. Are we having an announcement? Here we go. Negative 3 times negative 2 is positive 6, and 2 times the square root of 2 times the square root of 3 would be the square root of 6. Okay, and I'm switching to the black here. Now I've got negative 3 times positive 3, so that would be negative 9. And this is times the square root of 2 times the square root of 2, so that would be the square root of 4. Okay, now I just kind of want to see if I can simplify anywhere. So starting here, 15's factors are 1, 3, 5, and 15, and there are no perfect squares other than 1. The square root of 10 has factors of 1, 2, 5, and 10, and those are not perfect squares except for 1. The square root of 6, factors of 6 are 1, 2, 3, and 6, and none of those are perfect squares except for 1, and we don't use 1. Now, on this one, I do have something that I can simplify. The square root of 4 is something that can be simplified. The square root of 4 is equal to 2, so this would be 9 times 2, or negative 9 times 2. So one last step here, I need to just rewrite everything that I can't simplify, which is the blue, red, and green. And then I can actually simplify this. Negative 9 times positive 2 is 18. And this is complete. And they're quite a big problem, but you can see it essentially separates down into 4 separate problems which you solve simultaneously. Thank you for watching.